Welcome to John's Maths book. In this video, we're going to be looking at solving quadratic equations using the factoring or the factorizing method, where the coefficient of the x squared term is equal to 1. If you like these videos, then please like, subscribe, share, and add your comments as usual. A quadratic equation, when written in the standard form, is y is equal to ax squared plus bx plus c. When using the factoring method, we need to rewrite the quadratic equation in the form y is equal to a times x minus r times x minus s, where r and s are constants. Now, if we plot the graph of a quadratic equation for x and y, we find the roots of the equation are where y is equal to 0 at points here and here. So where the graph crosses the x-axis. So it's a parabola shape, so it crosses the x-axis twice. So there are two roots to the equation. So now let's look at an example of how to do this using the factoring method. So let's try and find the roots of x squared plus 4x minus 12 equals 0. So using the factoring method, we need to find two values or two numbers, r and s. So when we multiply r by s, it's the same as multiplying a by c. So in our case, a is 1 and c is minus 12. So that is minus 12. And r plus s must equal b. So in our case, b is the coefficient of the x term, so that's 4. So let's look at a couple of numbers that multiplied together give minus 12. So we can have, let's say, minus 1 multiplied by 12. That gives us minus 12. But when we add minus 1 and plus 12, we get 11. So that doesn't satisfy the need where we need b is equal to 4. It doesn't add up to 4. So let's try minus 3 and multiplied by plus 4. That also gives minus 12. But when we add the two numbers, minus 3 and plus 4, that only gives us 1. So let's try 6 multiplied by minus 2. So that definitely gives minus 12. And if we add the two numbers together, 6 minus 2 gives us 4. So that satisfies the need to have the two numbers equaling 4. So let's rewrite our quadratic and split the middle term. So we got x squared minus 2x plus 6x minus 12 equals 0. So if we look at this part of the expression first, we can remove x from it, and that gives x into x minus 2. And if we look at the second part of the expression, so this bit, if we take 6 out of that, so plus 6 x minus 2 equals 0. So now we have a common term, x plus 2. So we factorize this, we get x minus 2 is the common term, x minus 2 multiplied by x plus 6 equals 0. So now we have two equations, x minus 2 equals 0 and x plus 6 equals 0. So if we solve these two equations, we get the roots of the quadratic. So if we solve the first one, we get x equals 2, and the second one, x equals minus 6. For exercise number 2, let's find the roots of the quadratic x squared plus 5x plus 6 equals 0. So pause the video now and see if you can work out the answer. So hopefully you got the answer. So what we need to do is to find two numbers, r and s, when multiplied together, the same as a times c. So in our case, a is 1 because it's the coefficient of the x squared term, and c is 6. So that equals 6. So let's look at some numbers that multiply together to give 6. So we can take minus 1 and minus 6. That gives 6. But minus 1 plus minus 6 gives us minus 7. So that won't work. So if we have 2 multiplied by 3, that also gives us 6. And 2 plus 3 equals 5. So that satisfies r plus s equals 5 equals 2 plus 3. So now let's split the middle term of our quadratic, and that gives us x squared plus 3x plus 2x plus 6 equals 0. And if we take this part of the expression first, we can rewrite that as x into x plus 3. And the second part of the expression we can write as 2, so this bit here, into x plus 3 equals 0. So we have a common term of x plus 3. So if we factorize, we get x plus 3 multiplied by x plus 2 equals 0. So we now have two equations, x plus 3 equals 0 and x plus 2 equals 0. So solving these, we get x equals minus 3 and x equals minus 2. So for exercise number 2, let's find the roots of the quadratic. X squared minus 9x plus 20 equals 0. Pause the video now and see if you can work out the correct answer. So we need to find two numbers first. R, when multiplied by the second number s, is equal to a multiplied by c, which in our case, a is 1 and c is 20, so it equals 20. So let's look at some numbers that multiply to 20. So we can have 1 multiplied by 20. That gives 20. We can have 5 times 4 equals 20. And let's try minus 5 times minus 4, which also equals 20. So in the first case, we need to find r plus s, which is equal to b, which in our case is minus 9. So we need 1 plus 20, that doesn't add up to minus 9. 5 plus 4 adds up to 9, not minus 9, but minus 5 and minus 4 adds up to minus 9. So they are our numbers that we need for r and s. So let's rewrite the quadratic and split the middle term. So we have x squared minus 4x minus 5x plus 20 equals 0. So if we work on this part first, we can take out the value of x. and we're left with x minus 4. And then this part here, if we take out minus 5, we're left with x minus 4 equals 0. So now we have a common term of x minus 4. So if we factorize, we get x minus 4 multiplied by x minus 5 equals 0. So two equations, x minus 4 equals 0 and x minus 5 equals 0. So the roots of our equation in this case are x equals 4 and x equals 5 when solving the two equations. For exercise 3, let's find the roots of the quadratic x squared minus 9x minus 22 equals 0. Pause the video now, see if you can work out the answer. So hopefully you got the answer. Now we need to find two numbers, let's call them r and s, that when multiplied together, so r times s is equal to a times c, which in our case is 1 times minus 22, which is equal to minus 22. And we need to find r plus s, which is equal to b, which in our case is minus 9. So let's try some numbers that multiply, when multiplied together, to give minus 22. So let's try minus 1 times 22. That definitely gives minus 22. But when you add minus 1 to 22, you get 21. So not the same as minus 9. Let's try minus 11 multiplied by 2. That gives minus 22. And when we add minus 11 and 2 together, we get minus 9. So they're the two numbers we want. So let's rewrite the quadratic and split the middle term. So we've got x squared minus 11x plus 2x minus 22 equals 0. So let's look at this part of the expression first and take x out of it. And we have x into x minus 11. And then look at this bit and we take the value of 2 out and multiply it into x minus 11 equals 0. Now we have a common term of x minus 11. So let's factorize. And we have x minus 11 multiplied by x plus 2 equals 0. So we now have two equations, x minus 11 equals 0 and x plus 2 equals 0. So if we solve these equations, we get x is equal to 11 and x is equal to minus 2. So for exercise 4, let's find the roots of the quadratic x squared minus 3x minus 10 equals 0. Pause the video now and see if you can work out the answer. So hopefully you got the answer. So first thing we need to do is find two numbers, let's call them r and s, that when multiplied together, so r times s, is equal to a times c, which in our case, a is the coefficient of x squared, so that's 1, multiplied by c, which is the constant term, it's minus 10. And r plus s need to add up to minus 3, because that's the b term, b. So let's look at some numbers that multiply together to give minus 10. So we can look at minus 1 multiplied by 10. That gives us minus 10, but minus 1 plus 10 gives 9, so that won't work. So 2 multiplied by minus 5 also gives minus 10. So 2 minus 5 gives 3. So that satisfies the r plus s part of the equation. That gives minus 3. So it's the same as b. So let's use that and split the middle term of the quadratic. So our quadratic can now be written as x squared plus 2x minus 5x minus 10 equals 0. So if we work on this part first, we can remove x and multiply it into x plus 2, and then minus 5. So if we remove minus 5 from this part here, that gives us also x plus 2. That equals 0. So we have a common term of x plus 2 now. So we can factorize it. Give x plus 2 multiplied by x minus 5 equals 0. So we've got two equations, x plus 2 equals 0 and x minus 5 equals 0. So if we solve these, we get x is equal to minus 2 and x is equal to plus 5. So that concludes our video on solving quadratic equations using the factoring method when the coefficient of x squared is equal to 1. Next up, we'll look at using the factoring method when the coefficient of the x squared term is greater than 1.